Welcome again to the show. I'm Leslie Choyce, and my guest today is Alanna Mitchell. She's the author of Dancing at the Dead Sea, and also her new book is called Seasick, the Global Ocean in Crisis. Welcome to the show.
Thank you.
Well, the title sounds a little scary to me. Should we be frightened?
We should be so scared. Yeah, it's a scary batch of information, I think. I found it scary as I researched it.
Because the seas are changing and not in a good way.
Well, I looked at the global ocean as a whole, so as a whole system, and I looked at it as if it were a patient and I a doctor, or the scientists, doctors looking at it, examining its vital signs. The vital signs are all going in the wrong way. It's quite a distressing situation.
And you've actually traveled around a goodly part of the world. What set you off on this global journey to examine the state of the oceans?
You know, I think it became a scientific quest for me, because the first book I wrote, Dancing at the Dead Sea, was about ecological problems on the land. And I thought I understood it. I thought I got it, that I understood how all those pieces fit together. And I was right at the very end of researching that book when I ran into Sylvia Earle, who is a great ocean explorer in America, works for National Geographic Society and Conservation International. And I was bunking with her on a ship, a research ship, and she sort of tolerated me. You know, I mean, I asked her a whole bunch of questions. She was tolerating me, and finally, I said to her, "But you're a biologist. Why are you a marine biologist? Why not look at stuff on the land?" And she said, "Well, because the ocean is where all the life is." And the penny just dropped for me, because, of course, we're terrestrial, and we think that life is what we can see around us in the air, because we breathe air, and we think, you know, I've been to the Amazon, I've been to all of these parts of the planet where life is so exuberant and lush, and I thought that was life. But in fact, as I discovered, 99% of the living space on the planet is in the global ocean. So there's this whole part of the ocean, of the planet, that I didn't understand, and it was hubris. I thought I had understood it, and I clearly didn't, and so I just had to learn about it. And as I learned about it, I discovered how we're changing it, how our species is changing it.
And of course, even when we're looking at the ocean, we're just looking at the surface of the sea.
Right.
Most of us are not sticking our heads down below 100 feet, 1,000 feet, and
No.
checking out what's really going on there.
No, it's really notional to us. It's not even real. Most of us don't go more than, you know, even a few dozen meters down. I mean, really.
Yes.
Even divers.
Now, you begin the book with an introduction to Tim Flannery. Perhaps you could introduce him to us and tell me why he's so important.
Tim Flannery is an Australian biologist who has worked for many years to try to piece together a way to describe climate change, the science of climate change, to the public at large. So he's one of the key. He wrote a book called The Weather Makers, which had an enormous effect on
Huge, yeah.
on policymakers all over the world. And he's been on a campaign really ever since. Even though he's a biologist, he's been on a campaign to try to explain to people, to democratize the information about global climate change. So he's one of the few scientists I know who puts all the pieces together and who can communicate very well to other people. So I ran into him. I happened to be in Australia doing some research, and I ran into him on a beach.
Kind of inspired you to dig deeper and go further?
Well, it was right at the end of the research of the book, and what he helped me to do was to put all these pieces together, because that's what he's very good at synthesis. So he said, I described to him what I was finding, and I told him about what I was worried about and what my big questions were. And he just sort of casually said to me, you know, what you're doing is cataloging the death of a system. So it's worth writing the book in that way. And so he just allowed me to see it in those terms.
Mm-hmm. Now, climate change is affecting the seas, and in return, the seas are affecting the climate. Could you give us the basics as to what's happening in the big picture?
Okay. It's all about carbon dioxide. So just when we burn fossilized plants and animals from millions of years ago, which is what we do when we burn coal and oil and gas, that's just carbon energy that has come from the sun in a different era. But it's buried, so it's out of the budget of, you know, out of the recipe of today's healthy mix. So when we burn it, we put all that carbon dioxide back up into the atmosphere. And what we've done is increase the concentrations of carbon dioxide in the atmosphere. About a third of that ancient coal, that ancient carbon dioxide, has gone into the global ocean. A third of all of that extra that we've burned. And that is the lungs, that controls the climate of the planet through plankton, actually.
And then oxygen is reproduced that goes back into the atmosphere, or the oxygen
Okay.
stays in the ocean?
Okay, so as the carbon dioxide gets absorbed into the ocean, and again, there's no way of stopping that. That's just part of the breathing of the Earth. As the carbon dioxide goes into the ocean, it becomes chemically active and turns into carbonic acid, a slightly acidic part of the ocean.
Yes.
So it's making the whole surface of the global ocean more acidic. And when that happens, one of the knock-on effects is that as the ocean becomes more acidic, the calcium that's in the ocean is not as available to creatures to use to build their shells and their bones and their coral reefs and that kind of thing. So as it becomes more acidic, calcium isn't available. So creatures that need to build their shells can't do that.
So we're talking about like dramatic changes
This
of
is
many of the
huge.
life forms that are in the ocean.
It's absolutely enormous. It's bigger than science. I mean, one of the great scientists who first figured this out, her name is Joni Kleypas, and she works in Colorado for the U.S. government. In about 1998, was at a big meeting with a whole bunch of other biologists, and they didn't even learn about this stuff in school. This was thought to be a completely unchangeable element of the global ocean, the pH. They never thought about it, never thought that we could change this. And she and a bunch of other biologists were, literally making notes on the back of an envelope, figuring out what was happening to the pH level of the global ocean and then to the calcium ability of creatures to use calcium. And she figured it out, and she literally went into the bathroom and threw up because the implications are so enormous. We've already changed the global ocean's pH by more than 0.15 of a unit, which doesn't sound big, but it's in pH terms, it's enormous.
We're talking about the oceans with Alanna Mitchell, and we're going to take a short break and be back right after this.
If you'd like more information about this or any of the programs we produce at Mount St. Vincent University, call us or email. We welcome your comments.
Welcome back. My guest today is Alanna Mitchell, and we're talking about her book, Seasick. Now, the Earth's water, the oceans, it's warming up.
Right.
Is that necessarily a bad thing?
Yes, it is. It's bad partly because of what it does to plankton. So plankton are being hit by sort of a double whammy. The increasing temperatures of the ocean, the increasing temperature of the ocean surface, but also the increasing pH, the increasing acidity of the ocean. So a lot of the plankton produce every second breath you take of oxygen. They're the lungs of the whole planet. Plankton like cold water. They like to reproduce in cold water, and they like to have a very stable pH. So the plankton that have calcium-based shells, and not all of them do, but a lot of them do, are going to be less able to build their calcium shells. So they're going to be naked plankton. And what that does to their ability to photosynthesize, which is where, of course, the oxygen comes from. They get the energy from the sun. They're little plants, and they photosynthesize to produce food energy from the sun. And as they do that, they draw down carbon dioxide and emit oxygen into the atmosphere. That's how we get so much of our oxygen in the atmosphere.
Tell me a bit more about that, because that's kind of new to me, because I wasn't thinking about the ocean. I thought we needed to worry about the rainforests
Right.
and about the boreal forest in the north, because all these trees are regenerating oxygen from carbon dioxide for us. But
Right.
that's useful, and it's part of the big picture.
Right.
But
It
the
all
ocean is so much more.
It all has to work together is the real story. And yes, of course, the Amazon and the boreal forest both produce oxygen as well. But the majority of the planet's oxygen comes from phytoplankton. In the ocean.
Phytoplankton, how big are they?
Oh well, you could fit 20,000 of them in a teaspoon. Some of them,
Tiny
well, some of them are minuscule. Plankton covers even viruses and bacteria.
Right.
It's a huge, big tent of. And some of the phytoplankton sometimes become zooplankton, so some of the plants become animals, depending on what they, what they need to be at the time. It's a fascinating set of creatures. I just became intrigued by it. But they control the carbon cycle of the planet, is what they do, as well as producing oxygen, and not just carbon, but also nitrogen. So they are the ones that are the climate regulators on the planet.
Wow.
Yeah.
Now, what happens to the fish themselves in the oceans if the oxygen is depleted? The larger fish,
If the oxygen, there are big swaths of the ocean where there is little or no dissolved oxygen. So there are more than 400 of these things. They're called dead zones, and that's related to how much the top layer mixes with the bottom layer of the ocean. Because to continue to have dissolved oxygen in the ocean, you need currents and winds and things like that to mix it up. There are more than 400 big, huge swaths of the global ocean where there is very little or no oxygen. So I was on one of those. I was on a scientific cruise in the Gulf of Mexico, looking at what could live in this thing that they call the blob, which is a huge, it was 17,000 square kilometers just in area the year I was there, and that doesn't include the depth of it.
And why there? Why is that zone dead?
Why is that zone dead? Because farmers up and down the Mississippi River are using chemical pesticides made from phosphorus and nitrogen to feed their plants on the land, and it's leaching into the watershed. So it leaches in the watershed all up and down the Mississippi and runs down the Mississippi, goes off like a faucet into the Gulf of Mexico, and there's the food for the plants is still there. It's like a superfood for plants, not just for plants on land, but also in the water. So again, the phytoplankton go nuts on this stuff. They just reproduce like crazy. There's not enough other predators in that system to eat them. So they just die, fall down to the bottom of the seabed, and then bacteria start decomposing them. And as they decompose them, they go crazy and they use up all the oxygen. So you get this huge big zone that feeds on itself. And the problem with it is that it's unmixable. It's like it takes an actual hurricane to mix this stuff up. They've tried experiments to try to, let's just add some oxygen here, whip it up a bit, but it's just viscous, unmixable.
More to worry about. Are the seas getting saltier?
No, they're not getting saltier, but the patterns of salinity are changing, and that's worrisome. So there's, as I understand it, there's an absolute amount of salt in the waters, but they're getting fresher at the poles. So it's shifting around, these patterns of salinity. And that's a concern because it affects the currents, strangely enough, because salty water is heavier than fresh water. So if you have, at the pole, for example, at the North Pole, in the Arctic and the high Arctic, you've got a lot of water, a lot of ice melting, and that is fresh water, and so it's diluting the salinity at that part of the global ocean. So the conveyor belt that takes heat from the equator up to the north is slowing down and having a hard time falling and continuing in this belt of conveying heat and energy.
And here where we're sitting in Nova Scotia recording this today, of course, we should be very concerned about what's happening out there in the Gulf Stream and the movement of water in all directions.
Right, and it's not just because of heat. It's not. I mean, there was a scenario at one point of igloos in England. That England would somehow become a frozen mass. But that's not the big concern now. The heat that warms Europe really comes from winds rather than from the currents. But the concern with this current switching off is that it doesn't mix the water.
Yes, and so this could potentially happen. The Gulf Stream itself would shut down.
It could shut down, yeah.
Not good for places like Nova Scotia and elsewhere.
Not good for the world, because again, it's one system that's all interconnected. And the thing with the dead zones is, it's one thing when you've got chemicals, like you can envision chemicals running off the fields and into the Gulf of Mexico, creating this bloom of plankton. But the thing that's also happening that scientists have only very recently discovered, I mean, the first really big paper on this was in 2008, so a year ago, showed that there are now 3 massive dead zones that are informally productive currents that are being caused just by climate change. So as the temperature of the atmosphere warms up and the winds change, there isn't this mixing again.
And indeed, this is very frightening. Okay, we're going to take another short break. We'll be back with my guest, Alanna Mitchell, right after this.
This program is presented as a public service by Mount St. Vincent University.
Welcome back. My guest today is Alanna Mitchell. Her book is Seasick. We were talking about the world's oceans. Alanna, we know that we're losing ice cover in the top and the bottom of the planet. Why should I be worried in particular about the Antarctic ice shelf?
Because it affects the volume of the global ocean. So there could be substantial sea level rise. So we could, for example, lose Florida. We could lose Bangladesh. These are all scenarios that scientists are talking about very openly now.
Wow.
Yeah.
But these are things that are not necessarily going to happen tomorrow, but sometime in
That's right.
the
That's
future.
what they say. That they say that it could be that the sea level rise could be very minor in the next little bit. But the thing that is fascinating to me about climate science and ocean science is that every time the scientists make a worst case scenario, it turns out to be much faster and worse than they expect. In every case, it's fascinating. I've been covering this stuff for 10 years or so, and the scientists keep being surprised by how fast things are going.
Yes. Coral reefs are changing too. What's happening there?
Coral reefs are where a lot of the threats to the ocean intersect. So coral reefs need to be quite close to the surface of the coral animals need to be quite close to the surface of the water because they rely on little phytoplankton that live inside them, inside their cells, to produce food for them. It's a symbiotic relationship, and that's what gives them the colors. So when you see all those gorgeous colors on a coral reef, the colors come from little plankton that live inside the corals. But when it gets too warm, so they need to be close to the surface to photosynthesize. When it gets too warm, the plankton get expelled from the coral tissues. They have to, the corals just basically kill them off.
That's why I call it bleaching then,
And
going
that's why
back
it's
to
called,
being just white.
that's right, they go a
less
real
light.
neon white. I don't know if you've ever seen it, but it's really like the color of a bleached piece of paper. It's extraordinarily white. It's very uncanny when you see it in the ocean. And great big swaths of corals can have that happen. So what happens then is that the coral gets hungry because it's not being fed anymore. And sometimes the coral can attract other phytoplankton to live inside it again that will survive that kind of heat. But sometimes they can't, and then they die and they literally shred. So they need a certain temperature. When things get too hot, the corals can die. And when corals can also drown. So if the sea level rises quite a bit more than it is now, then these little photosynthesizers that live inside the corals won't be able to attract the sun. They won't be able to do their job. And so again, the corals will die. So they could drown, they could just sort of cook. And the third thing that's happening is the question of ocean acidity. As the ocean becomes more acidic, as we were just talking about, the coral animals need to use calcium and carbonate, so calcium carbonate to make their limestone shells, or not shells, but those structures or skeletal structures that they live on. When we think about coral reefs, we think about the bony parts. Well, that's all limestone, which is made from calcium and carbonate in the ocean. So as the ocean becomes more acidic, those coral animals can't use the calcium that's there to build these reefs that they need to build. And when it gets acidic enough, those coral reefs will actually dissolve in the acidity.
And now you traveled to the Great Barrier Reef in Australia, and did you find this damage happening there?
Oh, there's lots of damage to the Great Barrier Reef. Some parts of it are very, very good. They're still very pristine. Those tend to be in the north part of the reef, because the reef was seeded from Papua New Guinea, which is further north yet. And so there are just a lot more species in the northern part of the reef. But there are parts of the Great Barrier Reef that are in really tough shape.
When you actually traveled from place to place around the world, was there sort of some single thing that kind of brought it all together about what you were noticing about these changes?
Well, when I went to Plymouth, I went because they do a lot of research on Plymouth on plankton, and it was hard to find places where they were really looking at plankton, because plankton are, as we talked about, at the very top of the geochemical cycle on the planet, but they're also at the very bottom of the food web of the ocean. So they're kind of a keystone species, a key player in all of this stuff. So I wondered, one of the great questions, of course, is what will all of these ocean changes do to plankton? So I ended up going to Plymouth to look at what in England
Yes.
to look at what they were doing there, because it's one of the places where they've done a tremendous amount of plankton research over time. And I guess it wasn't just that they realized that the plankton are moving in the ocean. They can track what plankton are where, and they've been doing this for 75 years, so they can track changes. But they found that there is much less plankton in the northern sea than there used to be, because there used to be a whole bunch of little cold-loving plankton, and they've moved up north, and of course they're not as numerous because they don't have as much space to live, and these warmer plankton from around the Mediterranean area have moved up and taken their place. But they're not as populous. There's a drop of something like 70% in the numbers of these planktons. So,
And again, this is a danger sign.
well, it's just not a good trend. You know, it's one of those things, and I looked at that and said, well, what does that do to the ocean's ability to metabolize? Because if it can't metabolize, if those plankton don't work, it's not to say that all plankton will react that way, because I understand that there's some in the Southern Ocean that are more numerous, as you know, there's more heat energy in the ocean. But it's just a question of how will it all settle out.
Okay.
And plankton are, you know, they can adapt. They adapt really, really dramatically to different changes.
And we're going to take a short break, and I'm going to be looking for some good news. Yeah, so we're going to take a break, and I'll be back with Alanna Mitchell right after this.
If you'd like more information about this or any of the programs we produce at Mount St. Vincent University, call us or email. We welcome your comments.
Welcome back, and thanks for watching the show today. We're down here toward the end of the show. We've been talking about the oceans with Alanna Mitchell and hearing a lot of bad news. How do we turn this all around to save the seas?
Well, to me, it's about democratizing the information. That's why I wrote the book, because I figured, you know, I went around and found all these pieces of information and put them together. And it seemed to me that scientists were very anxious about what they were finding. They were becoming extremely pressed to try to explain it, and they don't really have a forum in which to discuss many of these issues. So for me, writing the book was to try to explain to people that this is what's at stake. I mean, all of this stuff is happening. It's not part of the public discourse. It's not part of the political discourse internationally. When we talk about climate change, we don't talk about, you know, the evil twin of ocean change, which is caused by the same thing. So to me, it's about, you know, once we have this information, we can hopefully do something with it.
Now, phytoplankton, you know, they're not cute, cuddly little
No,
creatures. It's
no.
kind of like hard to, you know, make the posters and
It
out there
is.
to help, you know, to make us want to preserve them. But
I know.
what are we going to do?
Well, scientists don't even know who's who in the ocean, even in plankton world. You know, there's a vast mystery to science. I mean, the goal, to me, it seems to me, when I put all the pieces together, the goal is to lower carbon dioxide concentrations in the atmosphere. So not just lower emissions.
That's the single most important thing that we should be doing.
No question.
So we're talking about cars and industry and every other thing
Heating,
that we burn.
we're talking about the engine of our economy. That's what we're talking about. But those resources exist. They're out there. The technology is there. We're just not employing it. We haven't, somehow, we don't seem to realize the urgency of this situation yet.
Alanna Mitchell, thanks for coming on the show and sharing this information with us.
Thank you.
And thanks for watching. I'm Leslie Choyce. I'll see you again next time.